Okay, welcome back. Now, in the previous discussion, we have learned about the domain and the range. All right, we know how to define the domain implicitly and explicitly, and also we know how to find the range of a function. Now, to find the range of a function, we will find the highest value of y and the lowest value of y. Now, in the following discussions, we are going to find the domain and range for various functions as stated here. Right, so we will actually find the domain and range for the linear function, the quadratic function, the cubic function, x equals to 3, x to the power of 3, right? And the square root function, right? Fx equals to square root of x. The absolute function, all right, f equals to absolute of x, f equals to absolute of x. The rational function, fx equals to 1 over x, where the x is the denominator. The sine function and the cos function, right, the trigonometric function. So we are going to discuss this one by one. All right, now according to the graph here, now we can see for a linear function, right? So this is called a linear function, and it is a straight line. So for a linear function, right, what are the possible value of x? Right, now, if the domain is not defined explicitly, right, it means that if the domain is not specially defined, then we will say that the x can be any value, right? The x can be any value, right? As long as we can extend the line. So the x can be any value, right? In this case, we say the x, right, can be any real number. Okay, so the domain x is a member of real number. It means that it can be any numbers. Now, how about the y? What is the lowest value of y? Right. Now, the lowest value of y can be any point here, right? It can be any point. So since the input is not defined, it can be any value. Therefore, the output also can be any value. Therefore, we will say the y is also a member of real number. Okay, all right. So the range, the highest value and the lowest value, it can be any value, right? Right. So the possible value of y can be any. So for a straight line, right, the domain and the range are member of real number. Now let's see the example here. Now sketch the graph of each of the following function and determine its range. Okay, now please bear in mind that according to the questions, the range is defined explicitly. It means that the range is given. Now in this case, the domain is given. In this case, the range is not real. It's not. It can. It's not any number, right? It's not infinity to infinity anymore. All right. It's not like this. All right. Infinity to negative infinity to positive infinity. It is not that case anymore. All right. So we need to sketch the graph. So first we sketch the graph for the first questions. 3x minus 4. So the slope is positive. All right, the graph is going up, and the y-intercept is negative 4. Right, this is the y-intercept. Therefore, all right, we will have, right, a negative 4 here, all right, all the way up. This is negative 4. Now, however, since the domain is given, right? The domain is given, right? The x is from 1 to 3 inclusive. Therefore, we are going to take the domain to substitute to find the range of y. So first, when the x is 1, we substitute here, and we can get the y is -1, right? So, right, let's say this is -1. So the graph actually starts here. Okay, the graph starts here. Therefore, this any value that lower than this, they are not valid. Therefore, we will have this value, right? The graph is actually set from this point. And when the x is 3, right, using the 3 here, substitute into the function. Okay, we will have the y is 5. So when the x is 3, all right, so the y is 5. Now, by sketching the graph like this, now we know that these are the possible value of y when the possible value of x is from 1 to 3. Okay, the value of x is from 1 to 3, and the possible value for y is from -1 to 5. All right, so this is the domain, and this is the range. So we write the range of y is defined as y, right, is greater than and is greater or equals to -1, smaller or equals to 5. All right. Now, alternately, we can use the algebraic method to solve. Right now, to use the algebraic method to solve, we first start with the domain. All right, that's one. And we try to change the x to the y. Now, what is the y? The y is 3x minus 4. Right, the y is the function. Okay, so first we multiply by 3, right, the inequalities by 3. So we times 3 here, we have 3. Times 3 here, 3 times 3, right, we get 9. And after that, we minus 4. So, right, minus 4, right, to get the y. And we have to minus 4 for this side on the left-hand side. So we have 3 minus 4 is -1. And on the right-hand side, we have 9 minus 4 as well. So we have 5. So we know that now the y is actually greater or equals to -1 and smaller or equals to 5. All right, so we get the same answer. So this is the range, and we can write in this notation as well. Okay, moving on to quadratic function. Now, as we mentioned earlier, quadratic function is actually a parabola. Right, so now this line can be extended to infinity, and here we can extend to infinity. So what is the possible value of x? So it can be any value, right? When we extend the line, right? So it can be any value of x. So we say the x can be any value, right? The x can be any real number. Now, how about the range? Right, now if we have the basic function y equals to x squared, right, this is the lowest value. All right, so the minimum value is always here, and this is 0. Okay, so the range should be greater than 0. Y should be greater than 0, and it can be any positive value. Therefore, we say y can be any real number. Y must be greater or equals to 0. So, to find the range of y, we always take this value, right, as the lowest value implicitly. Okay, let's take a look on this example. All right, quadratic function. All right, fx equals to x squared plus 2x plus 3. Now, to find the lowest value, we can use the completing the square method, or we can use the formula here, x equals to negative b over 2a. Now, I will strongly encourage you to use the formula, so this will be easier and convenient to find. Okay, so what is a and the b? Now, the a and b refer to, the a is actually the value in front of x squared, and the b is the value in front of x. All right, and if we have c, the c is the value without x, we say constant here. All right, now, so comparing to the function, what is the a? The value in front of x squared is 1. So the a is 1. And what is the b? The b is 2. All right, so in this case, we can actually find the lowest value. All right, the lowest value here, okay, the x will be negative 2 over 2a. Right, the b is 2 over 2a is 1. Therefore, we get negative 1. So when the x is negative 1, the y has its lowest value. So what is its lowest value? So we are going to substitute the x into the function here. So f negative 1 will be negative 1 squared plus 2 negative 1 plus 3. And we will get the answer is 2. All right, so the lowest value of y is actually 2. All right, so this is the minimum point. Okay, negative 1 is the x, and the y is 2. Okay, the y is 2 is from here when we substitute negative 1 into the function. All right, so then from here we know the lowest value is 2. And we need to find the highest value of of y. So since the domain is given, right, according to the questions here, all right, the domain is actually from 2 to 1. All right, now according to these questions here, all right, the domain is actually from 2 to 1. Sorry, negative 2 to 1. So we are using this domain, all right, to find the 2 points here. All right, so when the x is negative 2, all right, we substitute into the function. All right, negative 2 square plus 2x. Right, it will be negative 2 square plus 2, negative 2 plus 3, and we get the y is 3. So when the x is 1, we substitute into the function 1 square plus 2, 1 plus 3, and the answer is 6. Okay. Now, so from here, all right, we can imagine that, all right, for this point, when the x is negative 2, the y is 3. And when the x is 1, here, the y is 6. So finally, we can compare these 3 points, 1, 2, and 3. So, all right, the lowest point is 2, and the highest point is 6. We can say that, all right, the range of y will be greater or equals to 2, smaller or equals to 6. Or we can write in this form. Now let's continue for the rational function. All right, so this is called the rational function, all right, when the x is the denominator. Okay, so the rational function, if we sketch a graph, it will be something like this. So as we can see here, all right, for this basic graph, the x can be any value, right? So the x can be any value. Okay, when we extend this graph, the x can be any value except one value. The x cannot be 0, right? That for the y-axis here, all right, the graph will not touch the y-axis, so the x cannot be 0. Now the same thing goes to the y, the range. Now the y can be any value, right? The y can be any value, right? Up and down, but the y cannot be the x-axis, right? On x-axis, there will be no graph. Okay, on the x-axis, there will be no graph. Therefore, we say the y cannot be 0. Now, so these two lines is very important. All right, we call them asymptote. All right, the y-axis here, this line, we call that vertical asymptote. Vertical asymptote. And the x-axis here is called the horizontal asymptote. All right. Now the asymptote, it means that the graph will not cross the line. All right. So this line serves as the boundary for the graph. Right. The graph will not cross the y-axis, and the graph will not cross the x-axis on the other side as well. Okay. So now to find the domain and the range of the graph of the function, the horizontal asymptote and the vertical asymptotes play a very important role. Now, how to find the horizontal asymptote? Now, to find the horizontal asymptote, we can take the highest power of x. Okay, we can consider the higher powers of x and let the coefficient to be 0. Okay, we are going to discuss the detail later. Now, to find the vertical asymptote, okay, horizontal asymptote refer to the line like this. To find the vertical asymptote, to find this line, we can let the coefficient of the highest power of y to be 0. Okay, so for horizontal, we let the coefficient of the highest power of x be 0. To find the vertical asymptote, we let the coefficient of the highest power of y to be 0. Okay, let's see the example to understand it better. Now, let's say we have this function. All right, so now when we have this function, we know that the fx is always equals to y. So we can write the function has the equation y equals to 1 over x minus 1. Now, so when we expand this one, we bring the x minus 1 to the right-hand side and it become multiply, right? We have x minus 1 multiply the y, and this is equals to 1. Okay, we bring the x minus 1 to the left-hand side. Now, in this case, right, we expand further. We have xy minus y is equals to 1. Okay, now, what is the coefficient of x? Now, this is the coefficient of x. The coefficient of x right? Highest power of x, okay? Now, this is the highest power of x. The coefficient of the highest power of x is the value in front or beside the x. Okay, so y is the coefficient of x. Therefore, all right, letting this one be 0, right, y equals to 0, then we can find the horizontal asymptote. All right, so this is the meaning. Okay, to find the horizontal asymptote, we let the coefficient of the highest power of the x be 0. So we only have one x here. The coefficient is y. Let this be 0, and we can get the horizontal asymptote. So this line is y equals to 0. Now, next, how do we find the vertical asymptote? To find the vertical asymptote, we let the coefficient of the highest power of y to be 0. Okay, now, we back one step here to refer to the y. So this is the y. Okay, so this is the y. What is the coefficient? Now, we do not take the last one because we have two y's here. Okay, we back one step here. Now, this is the y, and what is the coefficient? The coefficient is this one. This is the coefficient, right? The value beside the y. So we will let this one be 0 to find the vertical asymptote. So when the x minus 1 is 0, so the x is 1. Therefore, the vertical asymptote is x equals to 1. So we have this line, right, when the x is 1. This is the vertical asymptote. All right. So then we know that, all right, the graph will be something like this. All right, from here to here, all the way down. And from the positive infinity all the way to the horizontal asymptote. Okay, now in this case, what is the range? Right, the y can be any value except 0, right? All right, the y can be any value except 0. Therefore, this is how we write the range. The range of the function will be the y can be any value except 0. Right, the y cannot be 0. So this is how we find the range, right, of y, the range of the function. Now, how to find the domain of the function if it is not stated, right? Let's say this is not stated. Okay, so then we will refer to the graph again. The x can be any value except this value, right? So the x can be any value except x cannot be 1. Why? Because when the x is 1, 1 minus 1 it becomes 0, and the function undefined. Okay. Now, let's consider radical function. Right, the radical function is actually the square root function. Okay, now for square root function, first, now we know that when we square root a negative number, right, you can use the calculator now and try, right? When we square root a negative number, all right, under the real number, it is not defined. Okay, so we do not consider the complex number now. We consider under the real number. The square root of a negative number is undefined. Right, so what does that mean? It means that, right, the value inside here, this value inside here, this must be a positive number. Then only we can find the square root of this number. So we are going to write the x must be greater than 0, right? Because it must be a positive number. All right, x must be greater or equals to 0. X is a member of real number, this is the domain of the square root function. Now, how about the range? Now, we mentioned that for this to be function, it has to be 1x to 1y. All right, so when the x is 4, we can only take 2. We cannot take 2 values, because if we have 2 values, then this is not a function anymore. All right, so if this is, all right, if square root of 4 give us 2 value, this is not a function anymore, because the function must be 1 value on x assigned to 1 value on y. Therefore, we are going to take the positive value only. All right, so in this case, right, the range is always greater than 0. The range, the y must be positive. Okay, so the domain of square root function, all right, the x must be 0 or greater, and for the range, the y must be 0 or greater. Now let's consider the example here. Now let's say we have a function like this, right? Fx is the square root of ax plus b. Okay, what is the domain? Now, first we know that the function inside here, it must be greater than 0. All right, so we will say ax plus b must be greater or equals to 0, right? The value here must be greater or equals to 0. And so from here, we will get ax must be greater than negative b, and the x must be greater than negative b over 2a. All right, so assume that the a and the b, they are positive number. Therefore, this will be a negative number here. All right, the x must be always or equals to negative b over a. All right, and the graph will be like this. Now, how about the range? Now, the y should be always more than 0, right? Because the square root here, we only take the positive value, right? We will not take the negative value. Therefore, this one will always greater than 0. So the range, for the range, the y is always greater or equals to 0. And for the domain, right, so it will be x greater or equals to negative b over a. Okay, now let's say we have a function like this, square root of x minus 1. Okay, how to find the domain? All right, first, we know the value inside here must be greater or equals to 0. So we have x minus 1 is greater or equals to 0. So the x is greater or equals to 1. All right, so we have the domain here. Okay, so the domain of f is defined as x is a real number. X must be greater or equals to 1. Now, how about the range? All right, now, so since the square root, we only take the positive number, so the range of the function, the y is a member of real number, the y must be always greater or equals to 0. So this is the range. Right. Now, we can also define the domain using the interval. Okay, now I would like to explain this one. Now, this is not a typo error, okay? Now, when we have a square bracket, it means that this is including, and the round bracket, it means that this is excluding. Okay, for example, let's say we have 0, 1. This one, it means that the x is greater equals to 0, right? The square bracket means including. The round bracket means not including. So we will have something like this. Okay, so alternately, if we have like this, it means that, right, is the 0 included? No. Okay. Is 1 included? Yes. All right, the square bracket shows included, and the round bracket shows excluded. So we can actually use this interval form to explain the domain and the range. All right, so we have 1 to infinity, and this is 0 to infinity. Right, next let's consider the trigonometric function. Right, let's consider the sine function. Now, if we sketch the function of the sine, all right, it would be something like this. So what is the domain? What is the domain of the function? Right, the x can be any value, right? So the x can be any value. Okay. So, and how about the range? Now, how about the y? All right, the highest value is 1, and the lowest value is -1, right? All right, so the y, the possible value of y, they are between -1 and 1. So we say the y is a real number, right? And, right, the y is between -1 and 1. Okay, so this is the range. Now, this apply to the cost function as well. All right, so for the cost function, all right, it's actually quite similar to the sine function. So for the cost function, the domain can be any value. All right, but the range, right, should be from -1 to 1 only. Okay, so the highest is -1 and the smallest is 1. So it's between. Now for tangent function, now as you can see here, this is the graph of tangent function. All right, so for x, now it can be any value except this asymptote, right? This is the asymptote. Now, what is the value of the asymptote? Now you can see here, this is the pi, right? This one is the pi. This is half of it. So it is actually pi over 2. Okay, half of the pi. Right, from here all the way to this side. All right, from here all the way here, this is half. So half a pi. Now, this half of this asymptote happen every pi interval. So from here to here, one asymptote. From here to here, one asymptote. So what is the difference here? What is the difference here? This difference is the pi, right? Okay, this is half a pi. From here to here is half a pi. From here to here is 1 pi. All right, so the difference is actually 1 pi. So this is what we write. All right, so half a pi plus, right, the multiple of pi. Okay, so the x cannot be pi over 2 plus 1 pi. All right, pi over 2 plus 1 pi. Yeah. The x cannot be pi over 2 plus 2 pi. Why? Because pi over 2 is here, plus 2 pi, 1, 2. All right, pi over 2 plus 2 pi. So this is an asymptote. So the x cannot be pi over 2 plus the multiple of pi. So the n is actually an integer, 1, 2, 3, 4, 0, or -1. So when -1, we will get on the left-hand side here. Okay, so this surf has the vertical asymptote, and this is the domain of the x as well. Okay, so for the domain of the function, we say the x can be any real number, but the x cannot be, right, pi over 2 plus n pi plus multiple of pi, where the n is integer. Okay, we can say the n is integer. All right, so this is the definition of the domain for the tangent function. And how about the range? All right, the range is for the y. Can you see, is there any limitation for the y? The y can be any value, right? Okay, so this is the graph for the y. It can be any value. So the y should be all the real number. Okay, so we have the domain and the range here. Now, next we have the piecewise defined function. Now, the piecewise defined function, it refers to we define the function, right, according to the portion of x. Now, for example, for this function, all right, absolute of x, okay. Now, when the x is positive value, here, when the x is positive value, right, the y is actually the x. Right, so when the x is positive value, when the x is 1, the y is 1. When the x is 2, the y is 2. Okay, so when it is a positive value, the y is actually the x. Now, how about the negative value? So when the x is negative value, smaller than 0, all right, the y is still positive value, right? So what happened? All right, the y is actually the negative of x. So when the x is -1, substitute here the negative of -1, we get +1. All right, when the x is -2, substitute here. All right, the y will be the negative of -2. All right, it will be 2. Now, we can see from here that all right, so the function is defined differently for positive x and negative x. For positive x, the function is defined as x. For negative y, sorry, for the negative x, the function is defined as negative x. All right, so we call this piecewise defined function. All right, now how about the domain? Now, to find the domain, we have to consider these two. Now, since there's 2, including all the values, so we say that x can be any real value. So this is the domain. Okay, we have to combine these two. Now, how about the range? So for the range, we have to refer to the y from the graph here. So from the graph here, the y can be any value, but must be positive. Therefore, we say, all right, the y must be real function. All right, and the y must be positive. Okay, so let's take a look on the example. Now we have this function, right? It looks complicated. Now we need to find the domain and range. Okay, so first, right, by using the piecewise defined function, the definition for absolute x. Okay, so the division by 0 is undefined, so it means that right, when we have the 0 here, okay, when we have the 0, when the x is 0, this one, this part become 2 times 0 over 0. All right, so this is undefined. All right, this is undefined. Therefore, first we know that 0 is undefined for x. Okay, when the x is 0, the function is undefined. Right, so we have this. X must not be 0 because when the x is 0, this part is undefined. Okay, now after that, now let's consider if the x is more than 0. All right, when the x is more than 0, we take the x is a. Now it means that this a is a positive number. When we substitute inside, all right, so we can simplify this. Now, since the a is a positive number, so we can have positive number divided by positive number. We can eliminate it, right? It can be eliminated, so we have a plus 2. All right, so the function will be x plus 2, right, if the x is positive. Now, if we consider x is negative number, we take x equals to negative a. All right, the a is positive number, but we have a negative in front here, all right, to show that this is always negative number. So substitute into the function here. So we have negative a plus 2 times negative a over the epsilon of negative a. All right, and now we know that after the modulus, this negative a now become the a. And we can simplify this, right? Simplify this too. So we have negative a minus 2. So, all right, so when we have fx, it will be x minus 2. All right, the x is negative number. All right, now take note because this is a negative number and we consider the x is a negative number here. So it becomes x minus 2. All right, so now we can actually sketch the graph like this. Okay, we know that this line can be extended. This line can be extended. So what is the domain of x? What is the domain of f? The x can be any value, right? X can be any value. So we say the x can be any value except the x cannot be 0. All right, now how about the range? Now for the range, refer to the y. Now the y, now this is the graph, right? This is the graph. We can see the y can be any value, right here. The y can be any value, all right, less than negative 2 and more than 2. Now you can see for this part, no graph. No graph, it means that, all right, the y does not have any value here. So we will say that the y, all right, is any real number, but the y must be more than 2, right? The 2 is not included. And, okay, one more. The y must be less than negative 2. All right, so this is the range of y. All right, so now as a conclusion, all right, a function from x to y is one-to-one function. Okay, when each of the value in x, all right, is assigned to one value in y. All right, so we say this is one-to-one. Now you can see here this is not one-to-one. All right, because 3 and 4 they are actually assigned to the same value. Okay, now however, in this function here we can see all the element in y, they are assigned by one value in x, right? So we call this onto function. Okay, when all the value in y they are assigned has by one value of x, this is on 2. And if one value of x is assigned to one value of y, then they are one-to-one function. All right, so now this is how we find the domain and range of a function.